Hello everyone, my name is Suman from Uplatz. So the module we are discussing currently about statistical concepts using R language. So we have been started with very basics of statistics, what is statistics and what things it can able to do it. And we have been went with a couple of examples, including data frame, right? So these are the things we discussed it. Now the question comes to here is, I'll just open the notebook and I'll explain. So, like I explained, descriptive statistics is there. Similar way, we do have inferential statistics also available. Okay. These are the topics we covered. First, we understand very basics like what is statistics and what it can do and how it can able to help in AI career. And we have been gone through variables like types of variables and their whether they are numerical or categorical. If it is a categorical, then what is further nominal scale and ordinal scale. Okay, table and ratio. Then we went with centered tendency, and where we have been understand a couple of the things like mean, median, mode, variability, and we have been understand the similar concept. We have been went with a shape. So these are the covered topics. Okay, so which we discussed it. And what is this? Which I explains quantiles. So by looking at quantiles only, we can able to tell, what sort of shape is its holds. Okay. So how do we know and what sort of things we have to understand? Let's say, consider as here is simply evenly distributed. Okay. So evenly distributed, how we can say? So I have taken simple example how this can help us to provide better data. So first thing, evenly distributed, you can take it one comment, this comment, but we have to understand comment comes from these 5 variables data. Okay. So 1, 3, 5, 8, 10 is there. So if we look at here, 5 is the middle of 10, we know it. Okay, so that is median. And here 5 plus 3, 8, and 5 minus 2, 3, and 1. So it's a equally change, small changes. So that's why it is evenly distributed. Now, going into 1 after 4. So this is towards 5, very near. And 5 hours, then only just 6. So that is the reason most values closer to the center. Okay. So here closer to the center in the sense like, 5, this value 4 and this value. So I'm telling these examples with simple numbers, but in other cases, we might understand. Okay. Maybe 1,000 marks are there, 1,000 marks. 1,000 marks, last is something like, take it as a 98, 100 marks, fine. So maximum value, a person who got 98, who are a couple of people. And somebody third quartile indicate something like 74 or 76. And middle indicate 60. Okay. Now, in that cases, their marks, I'm not telling 1 to 150 is a middle, yes, that is middle 50. But we taking their data different. Okay. So they are not getting into something like, this is something like 55. First quartile itself is 55. Then in that case, something like first value is something like 25, first quartile, and this is something 30. Then that is called evenly distributed. Okay. So most value close means we can understand most nearby 50 marks more. Of course, few people, but most people are nearby. So these three, minimum is same. Here we can see maximum is same. But whatever these three, first quartile, second quartile, third quartile, this is also called as second quartile. But these three indicate the shape of the distribution. That's the main thing you have to focus on. Okay. So that's one perspective, and we can able to got it to understand. In the similar way, we have been came to understand with the single 3 variables, and we have been understand about a couple of things. Okay. So this is okay, we understand, but what generally shape knows for us, knows to us. See, the simple example state is there, that's good. But the problem is, if you go ahead with any certain values, like something like, any certain values, if you want to look at whether they are closer to mean or closer to, median or closer to something. So in that cases, we can able to understand. So that is the reason, we will get to understand in a simple way of looking the data, how they are distributed along with shape of the data. So the shape will explains clear information about and including values, okay, include values and similar way we can able to understand how these data will be distributed accordingly. Okay. Now the question comes to here, can we able to explain like inferential statistics in perspective of let's say uh, in a Indian or maybe other context, okay, other contextual data, other contextual real life scenarios. If I take it any scenarios now with our programming languages, especially as it programmatically mm, uh, all the topics, like all the topics is in the sense, all the main topics you can say, all the main topics once we covered, with along with information along with scripting. Then we can able to understand. Similar way, however we understand differential like descriptive statistics. In the similar manner, we can able to understand inferential as too. Okay, so similar concept we will move ahead. But before that, let's move ahead and understand what are the rest of the things we do have. So like this is box plot, which I explained clearly. Box plot is a type of plot, but it will provide plenty of information for the data which is numerical. Okay, let's take it a marks, because marks you can easily understand. So marks of the students or prices of the some house or prices of the some products or maybe ages of the people. You might consider as real life data anything, but what it provides box plot. This is a box plot. This is called box and these are called whiskers. So that's why this is called box and whisker plot. In short, we can call as box plot. What it gives us, so this is one line and this is one box and middle one line is there and this is one line and some dots are there. This is a general scenario of any box plot. But the question comes to here is what is this lower values dots indicate? These are nothing but outliers, means they are far away before the first quarter. And what is this value? This is minimum value in the data Q1 minus 1.5 times IQR. Okay, so that is a value which indicates, and this is the maximum value in the data totally. But here we have to look at the minimum of maximum value in the data of Q3 plus 1.5 times IQR. What is IQR? IQR indicate interquartile range, means Q3 minus Q1 indicate IQR. So this difference is nothing but, so here we can see this is Q1, this position is Q1, and that's also called a 25th percentile or first quarter quantile or first quarter we can say. And this is indicate second quantile, or also we can mean it as 50th percentile, or we can call it as a median. This is 75th percentile, or we can call it as third quartile, because we have been divided into data into 4 parts. Like you can consider that 100 is there and 25, 50 and 25, sorry, 75 and 100. So that is the main goal here. But in our data, we can't say every value comes from 1 to 100. In general, that is 1 to 100 scale. But the question comes to here is IQR, and it will explain clearly, what is, IQR. Then you can just go for maximum of, this value. This value is what? Maximum. Maximum of what? Minimum value in the data, Q1 minus 1.5 times IQR. So that is this value. This value indicate Q1 minus 1.5 times IQR. And this indicate Q3 plus 1.5 times IQR. So these edge indicate Q1, these edge indicate Q3, and these edge indicate, these point indicate Q2 or median. What are the rest of these are? Those are potential outliers. In more senses, we can say this is lower very far. But we take it as a marks in the simple example. Here person got 50 marks, here person got 25 marks, and here person got 26, and here person 30. Now, what is first quartile? So that is 55. Then what is this value? So 55 with compare with 30, it's very far away. Like that is a mechanism. Now go ahead here. This might be 85 marks. This is 90 and 95. Not 85 nearby. Let's take it as the 70 marks. And this indicate 93 or 94 or something like 99 or something like 100. Now question comes to here. When I compare with this value, and this will be very far away, but we have to take it outliers, and it will explain clearly how these outliers will explain the box plots. So this measure of shape in general, okay, and this is also known as it will explain whether the shape is skewness or whether the shape contains like skewness and kurtosis. These are the main things we have to focus on while looking into shape. Okay, what is skewness? Skewness measure the symmetry, means more specifically we can say a distribution of the data set which is symmetrical if it look like same in the left side and same in the right side. So that is skewness will indicate. Kurtosis. Kurtosis is a parameter that describes the shape of a random variable's probability distribution. So this is about I'll just give it as 3 diagrams so you can make sure to understand. So here skewness is positive, means most of the edges are here, but very few people edges are here. Take it as a simple edges of the people, and very few people are 80 above. Very few people in the sense like 2 people are there, maybe 3 people are there, 1 people is there. That is lower. When it goes to lower age, maybe you can take 15 or 20 or maybe 10 or maybe 25 and below 30. Those people are more. So that is what here. So this indicate ages. This y-axis indicate count. Count means how many. Typically, you can take one example. For example, there is a school is there. A school is distributed. Suddenly, school is end over. Now, you are looking the ages of the people. Okay. You just collected after end of the school. Suddenly you are going with some count of their people, or you are some asking their ages. Now what is happening? So obviously school age is very low, no? So most of the students are there here, so lower age. Now what is this? Maybe their friends, maybe their parents just comes to there. So we can't say one parent contains only one kid. So definitely he has maybe 3 also. Or some people they don't without kids also, without parents also, they will go ahead with maybe by bus or school bus, or individually they have something like right now bicycle or something. So their ages is matter. Forget about their relationship. But ultimately, if you collected the group, okay, so maybe a brother can also go to school of the kid, and he can also pick up, right? But we have to consider most of the people ages are here. Now coming to down forward here, down forward here, the same data you can take, but I'm going to there like elder like in that kind of something. Okay. So in that cases, okay, in that situations, definitely elders will be more compared with previous people. Okay. So you can take any certain example in real life. For example, elders they have provided maybe outside they can live with some ashramas or something. Okay, in that cases, or maybe temples, something like you can take. So in that cases, we will find most ages people are here. So that is what indicate here. But if you take typically randomly, for example, you just go to generalized data. For example, let me consider as a bus stop or something like railway station. You can't find a single person, single nearby age people. You can find multiple ages people because uh, maybe five people may be small age, five people may be old age, five people may be middle age, five people may be like young age like 25 or 30, and five people may be something like middle age. Now in that cases it might be zero. Okay. So this indicates positive, this indicates zero, this indicates negative. That is what skewness. Okay. So skewness by number, I can able to tell, okay, these people are more, these kind of people are less, these kind of people are more. Now I'm telling age, but instead of ages, you can take prices of the products. Now what is prices of products in these cases? For example, this is lower price, this is higher price. Now a company is having they make it a plot their monthly sales, they are plotting, and they have same graph they got it. Now what they understood? They understood lower prices are we got more. Lower prices are companies are preferring ourselves rather than higher prices companies because counts is more lower prices. Now coming to here, okay, coming to here. Now lower price is here and slowly increase and higher price here. Now here you can look at higher prices count is more. So in these cases, I can say higher prices is more, right? So you can take like infrastructure related or some real estate or something. Definitely higher prices will be there. So this is only small price. Now going to here middle, something like lower is there. Some people prefer some higher prices also they are preferred. So in that cases zero. Now the number indicate and the shape indicate how these values are distributed. Okay, so that is the main mechanism. Now what is kurtosis? The kurtosis indicates, for example, if the data is here less than 3, that is a number which indicate less than 3 indicates platycutty. Okay, means the data will be like this, and equal to 3 indicate, and that is called mesocotic, and greater than 3 indicate. So here indicate what main mechanism here we have to understand. The same 0 you can consider as this value, and same 0 you can consider this value, but same 0 you can consider this value. Now what is they observed? See, they observed whether the graph is like this, okay, or whether the graph is slightly increasing, and whether the graph is slowly here to here. Okay, so here height is matter. Ultimately this height is matter. Okay, so height is explains this height, entire height relevant to each graph. Okay, this value height towards what? Towards center. Towards center we are looking, but how the graph is look like. So if the graph is something like here to here and slightly decreasing here, now we can say this is leptocotic. Okay, this is there. And if you go here, just like same as this, we can see this and this is same, almost nothing changed, but this is only changes, and this is only changes, and these two changes. Okay, now what we understand from these 6 graphs, we understand how these count of people are we can able to understand. That is the two mechanism, plate of skewness and kurtosis. But once we know the number, we can able to tell how this skewness works and how this kurtosis works. So here for skewness, measure of symmetrical distribution. So 0 means the distribution is symmetrical. Okay. Less than 0 means so the value of the mean is less than the mode. Greater than 0 means the value of the mean is greater than the mode. So that we can indicate from the box plot method and the meanwhile distribution method. Okay, we can say density graph. Density graph we can say or histogram we can say. So density graph, these are density graphs similar. Okay, so these are density related graphs, but we can say this graph is similar to explain box plot. These the graphs similar to explain distribution of the data. But with these three graphs, with three types of graphs, there are plenty of information is there here. Okay, so that is a main mechanism you have to provide it. So summary of when to use mean median mode. Okay, we understand in the initially central tendency is there, sir. Something like we know it, and we know it a mean, and we know it a median, and we know it a mode. But when should I use? That's important. And where should I use? Okay. So I give it here simple diagram. So to understand type of variable, your type of variable is nominal. Then you have to look for the mode. Why? Best measure I'm giving. Best measure means, for example, you have nominal you can consider as a favorite foods I'm asking a persons. Maybe 100 people I'm asking favorite foods. Now in that cases, no need to go to median because that is a categorical data. Now, what I want to look at, mode is better because mode is nothing but most repeatable. I'm asking favorite food only. Like early, which I remember, I asked what is the favorite play, right? So favorite play is nothing but I have to look at which play is most people likes. Okay, and in these cases, which fruit is most people, buying in a fruit seller perspective. In a playing perspective, which player is more. So that's why I'm telling in India, most people they will say, nah, generally because of we know it, and recently also World Cup in T20. So this is what we know. But if you go to outside India, football might be right in US or something. Cricket is very less. Other countries, maybe US or other countries. So in that cases, definitely mode should be changes. Okay, they might say favorite food or favorite like play might be football or hockey. Hockey also better for India, but that is one example I am telling in general. But make sure to understand. Ordinal is there. Nominal you explain. Ordinal is you explain. Then what I should do? Best measure is what? Percentile tendency. Ordinal is there. Then you have to look for the median. Why? Because you are making order. Okay. You are making order. So there is a ordinal is presented. So I have to look for the median that indicates best measure. Okay. And that's indicate best central tendency. Okay. So for example, you can take rank of people, something. Then I have to look for the most of the people are there. They're middle. Okay. Because we know it, topmost and we know it, something like, last, most of the people. But ultimately, median indicates, best measures center of tendency. Okay. Now, interval ratio is there, numerical. Okay, this is nominal and ordinal categorical. That's fine, we understand. Interval or ratio is there, or this is also interval or ratio. Then what we have to look at, if the data is not skewed in the sense like this value, this graph. So this is not skewed, 0. So for this graph, I can make sure to go ahead with the mean because that is a median value. Now skewed, then what I have to look at? So we have to look for the median. Okay. For example, this is also skewed, this is also skewed. So most of the people are there median. So here median right side, here median left side. Okay. So that's where we have to move ahead and we have to make sure to understand how these graphs are related with groups of people like sample or population and how these graphs with related skewness, with related kurtosis, with related to distribution, and with related to density, and with related to a box plot. So all these things are mixed up. Okay, all these things can explain plenty of information. So that's what we can say. And skewnesses and kurtosis here will get. Now in the similar way, I explained formulas. So formulas in the sense like, in general, we can say mean indicate mu symbol, okay? Or we can call as expectation of X. X is nothing but group of people. It's not like, X is not one person. Group of people ages, group of people prices, group of people, group of products prices, or group of something like, some like sales. Okay. So that is what X. But every X is group. You just consider. But mu indicate expectation of X. Already we know it. Summation by count. Variance indicate X minus mu whole square expectation, and we will call as sigma square. Standard deviation is square root of sigma square. So that is the reason we call it sigma. And skewness indicate what? Expectation of X minus mu whole power 3 by sigma power 3, and kurtosis indicates similar way expectation of X minus mu whole power 4 by sigma 4 power 4 minus 3. So this is called, this symbol is called skewness, and this symbol is called kurtosis. So that is generally we can look at something like in a box plot. Okay, I mean in statistical books. So what is, how to find it? What should I have to go to? So there are a list of packages are there, like where we can find out skewnesses and kurtosis. Functions are presented. So I'm giving the packages here. Movements is there. Desk tools is there. E1 is there. 107 is there. F basics packages is there. So these are a couple of packages we can make sure to understand. And this will provide those information. These are all packages. Now we can understand, how to get it that way. Because we know it already early, I explained how to get mean. Simple mean function is there. Median function is there. Mode function is there. Everything is there. We have been gone. Similar way we understood about variance. Similar way we understood skewness. But okay, but finding skewness and kurtosis will explain how the data will be distributed, and how the values will be they are distributed. Okay, so for this we have to install these packages. So I'll just long back I just run out this method. So I just want to install here. So I just want to install here itself. It's again will take a couple of seconds time. Let's move ahead. Like I explained, this filled color circle indicate busy. Okay. Meanwhile, you can do it any task or something, or you just wait for it. And one more thing which I explained, while installation, you need compulsory internet connection. After installation, no. I mean, any package, we need internet. After installation, without packages also, you can practice it. So one time if you install, like which I explain, any package. So we are going into plenty of packages in our language. So I'm just explaining how we can work on. And these things will explain, better mechanism for, getting the data and understanding the concepts. And one more thing is, while installing any package, dependence packages is also there. For example, this is one package which is downloading and installing, but dependence package is also installing. Okay, so that's what we can make sure to understand. That's also first thing. Now, okay, we installed it. That's good, and I have taken some time and some variables. So you can see randomly I have taken 19.09, 19.55, 155, 17.89 and so many things I have taken. And I'm going into my library called movements. Okay. And I'm asking skewness. Okay. When you just install movements, then you will get skewness, otherwise not. Now, similar way, I'm asking for time. Okay. So when I just question it here, let's try it or run it. We got this part, this example, right? So minus 0.01 and here 2.31 and something near, nearby 3. 2.3 nearby 3 we can't say, but this value. Now go ahead here and understand here. So first is minus, right? So minus is value. Minus skewness and kurtosis. Now, according to this, what we understand, according to this, what we understand. So here, it's a clearly gives us a symmetrical distribution, and zero, the distribution is symmetrical. Less than zero means the value of the mean is less than mode. Okay, we understand here. So the value is mean less than mode. So it's indicate less than, and greater than zero indicate the value of the mean is greater than the mode. Okay. Now question comes to here is you can see. So 0 we got it, 0 less than 0 we got it here. And we clearly understand about that is very less than. So the mean is more in these cases. Okay. So it's going to towards the right. Okay. Then we can say it's something like the curve might be like how the mean value, mode value, and how the curve will be look like. And skewness is 2.3. Okay. So 2.3, which I explained here simply, like 2.3 in the sense like just go to here. So 2.3 is not less than 3. 2.3 is less than here. So it should be like plateau kind of style. Okay. And here, so median, and here median more. So this will be negative value. So that we can say. So what we understand from these two graphs. So the kurtosis, I mean the graph will be like this, platochotic, right? Platochotic, not exact platochotic, less than 3 in the sense like similar way, and it's look like negative value, right? So this is negative. We got skewness, but with this example we understand these things. These might be related, so these are not related for that value, for that data we are giving. Okay. For the data we are giving, whatever we are making graph. So that will be there. These are two related. Okay. Now, how they are related? You might say, see, it going here maybe slightly, towards negative, but here just giving into right side like this. So that's what Plato contains. Join it, this just combine in the way like, join these two generally. And what you can look at combinedly, and so that's a mechanism it follows. Skewness kurtosis is nothing but in the similar way. So it's a platochotic and it's a skewness to the towards the left, we can say. So that is a graph which explains it is simple data we are taking and we are just working with the projects, and then we can able to understand. Okay. Now, in the meanwhile, we'll just take one data set and we'll make sure to understand how these values will work. So for that, what I have taken here, there is a data set which presented for Titanic data set. So this, if you go to data, so there is a, data one is there. I'll just provide here. Train one CSV is there. Now, if you want to directly open, you can open here. Train one.csv, just open. So the CSV file is directly displays. What it indicates? It indicates Titanic ship incident data. We know it already, not for just don't think like a movie, but Titanic ship accident happened. Accident in the sense like the entire ship has been sink really. It's a real incident only. They made it as a movie. Okay, it's a very large ship, and most of the people are dead, but some of the people are survived. Now question comes to here is, that is the data, but this is the original data, which has they have, because they have historical data, they have everything information is there, like passengers or something. information, just like the registration is there. They have these things. For example, I will explain passenger ID, and this is surveyed means this person is dead. So Brad, Mr. and something over, and this person is surveyed. So surveyed, how he surveyed doesn't matter. Whether they have taken small ship or whether they had, swimming and, waiting for, other person to be, make sure to survey. But ultimately, this person is not surveyed, this person will be surveyed. So in that cases, we can say. But what is that passenger's class? Passenger ID is ID, serial, but passenger class is different in their concept of a passenger class. For example, if you go to movie, so there is a ticket is there and something like number is there. Similar way you can consider. But everything we can say like first class or something like box or something. And if you go to lower something like a very basic class is also there. So in that cases we can say name of the person and gender, sex, whether male or female, and this is the age of the person, okay, and this is what their ages, and they're traveling with siblings or spouse, okay. For example, this is a person, okay, and a sibling spouse, one person is also here somewhere there, one person, and here parent or child. So the person is traveling with parent or child or siblings or spouse, and this is the ticket number, and this is how much fare, okay, and this indicate that they have separate and this is indicate station which has been going to CSU 3 stations and travel from 3 stations. So that is the reason they are giving here stations. But some of the people are not taking cabin. So that is also indicate person who has been dead or not. So why? Because we don't know. But if you look at the structure of the Titanic ship, so person who are very nearby some outside or something, they might immediately jump and something like they can be chance skip out. But the problem is even the sink is happening like sinking a ship in the some sea. But there is a small boats is also there. Early, if you go to any big ship, so they will take precautions. So they don't go to directly, without any precautions. So if you go to any big building or something like large building, so we do now we can see fire related early they will make it machines, right? Somebody sometime you will get a fire, you don't know, but ultimately that's a precaution you have to take. And they will clearly write if you go to any something like any shopping mall or they will clearly mention, okay. So wildfire you can't go to steps, you can't go to the lift, but you have to follow the steps only. If it is something like 4 floors or 5 floors, okay. And at the place of there also they will fire, safety, they will missions, they will paste it, okay, like gas related or something which is stop that fire, okay. So why they are giving that thing? Because we don't know when something is happening. We don't know. So similar concept, Titanic we can understand. That is related to ship and traveling. And that is related to how to overcome if some incident happening. So now this data I'm taking. This is a real world data only. In the similar way we can consider as I'm taking here, and I'm just loading here, and I'm looking for this just first 6 values, and we got it here. So now it's clearly indicate this data, right? So this data indicates passenger ID, surveyed, everything, data frame which contains 6 only because head is provide 6, but it contains multiple, values. So DIM will explain, a lot of things, but it will, how many is there? But header is what I'm giving T. Shortcut is also fine, or you can write 2 either way. Now question comes to here for this data. Can we able to find such kind of values? Like whatever we explain. For example, here is there. Pair is there, here train is there. And train is the data frame, pair is the column. So for every column, if you want to get any data frame, so we have to give that dollar symbol. Okay. So trade, dollar symbol, and fair, we got it. And here I'm using library desk tools. Okay. Why? Because I want to look at mode. Okay. So the mode is a part of, for example, if you go to here and something mode is a direct, we have a return function, right? I want to load it here, library. I just write it something like this tools, right? Capital T. So when I got it here, let's see, because that is different version, this is different version. Now we are getting errors, right? If I look at here or just type out here, put a mark, and here I am just asking mode. Okay. In these cases, you will get outside of the search word, search words. Okay, let's try it here instead of all these things. Just type it what are test tools. You can see. Okay, so this is mode. Then we might say, sir, already mode is there. Why you are creating custom mode, custom function? See, instead of all going into first time package, so you might confuse. But we have to know the logic. What is mode? So that is the reason we have to create a custom function. But here that is also directly available capital. Okay, capital M we have to write. But if you go to mode, this is different. This is not mode. This is also similar to Word, but this will gives us just what type of data it is. For example, train I am taking, and I'm just taking age. Now it will clearly mention age is a numerical data, so it will clearly mentions it's a numeric. Okay. Now go to your name same way, and I just go to name of the persons, right? Or you can direct directly. So name I'm just typing, and it's a given character oriented. Yes, so that mode is different. This mode is different. So this mode indicate most repeatable entity. Okay. Now I'm asking age and I'm writing mode. And I'm also going to table and I also same work on of the age. And I'm also going to median. I'm also asking the fair. Now we got these values. Okay. So package this tools was built on our 3.3 version. Okay. So we got it here, these values. And whatever we got it here, one value we are not getting. For example, in these cases, library, okay, fine. And if you just go ahead here, okay, fine. Okay, so we are looking the data here. So since tool is presented in others, so that is the reason we are not getting more directly. But other versions. But if you want to, you can download it and from the CRAN and we can install it. That's also fine. And here, okay, mode we are asking, but most repeatable mode we if you go ahead with some names mode also something or just try it here. You go to my R Studio. Let's try it. Just go to install. I can take any values 23 and 56 and 78, something I'm given. So we are getting in here, right? Now get 78. Now we got 78. Okay. So what is the difference? See, it's find the most repeatable entity. 78 two times, no? So we got it here 78. Okay. Now give it something like 67 and 67 and 67. Let's try it here. Now we got what? 3. Okay. So 3 we got it, but 67 we got it. Now let's remove these 6. So because that is 3 times. Now both are 2 times, right? So, but it's giving clearly one is 67, one is 78. Okay. Both happening 2 times. Okay. Both happening 2 times. And here, most of the value is 67. That is the reason we got 67. At the same time, we are getting also how many times it's there. It's finding single mode. It's giving count. If it is a double mode, so double mode indicate double. It's not double mode indicate double values or but double values similar frequencies like 2 times. Okay. So in these cases 3 times. So that's why it is dominated and we didn't get 78, but we'll get frequency means how many times. So 3 times 67 is there. In the 78 2 times single value 2 times we got it, but in this cases there are 2. Why there are 2? Because here 2 and here 2. So it's a frequency value. Okay. Now similar way you can practice other data. So that is what mode, the similar concept. So this in these cases we are finding such kind of values, but we didn't get because of versions or something changed. But we can make sure to understand how these values are provided. What table is provides? See, table provides couple of information. Okay, like we can see a table asking on the top of faith. Okay, so on the top of table asks top of the age. So it will give how many times the such age will be repeated. Okay, so that is the value we are getting here. Some raw data, this is raw data which we have taken, but we have to understand how these values will be fair to enough. Okay. Now second cases I'm taking more such values like variance. Okay, so variance we know it. I explain how these various values are like for along with the mean. Okay, so that's what variance. Now, square root of variance, obviously we'll get standard deviation. So that is the reason we got same thing. 24 we got it, 24, 69 point something. That is variance. And this square root of variance and similar way of other values, and we got same information, right? So just we can make sure to understand here. So this indicate clear information, clear information about how these values will be make sure to provide it. Okay. So that's about finding in the similar concept. So I'll just go move forward and we can able to understand range as well. The range is nothing but which I explained clearly. What is the highest and what is the lowest? Now, the early previous version we got it, but right now if you run it, because these are inbuilt functions, you can just directly run it and you'll get here clearly. Okay. So calculate range and it's indicate what is the value which is it shows the lowest value and highest value. Okay. I think 0.5 point or something. I'll just split out here. 0.51.2, right? I think 0.512 something is the lowest, or you can ask here mid. And similar way, we can take a tree, and similar way you can find out fair, or you just type it every time, just fair only. It's not getting tree. Train you can type it, and fair you can type it. It's coming into total, right? How to yes, we have to type total, I think. Okay, okay, no problem. We'll look at. So here minimum we are getting, you can see we got 0. Okay. The same value copy paste. And here instead of minimum, you can ask max value, and you'll get it here something like 5.1, 512.4. Okay. So that is these values. Okay. So here 0 indicate this value and this indicate what generally. So next value 5.1. So that is a range. So don't make confused. So now I'm questioning in the same way, whatever we discussed in the similar concept of box plot, but I'm asking, couple of things here. The box plot is direct method. You can use a box plot on top of age, compare with what passengers class. And I'm giving X label and Y label, and I'm giving column uh, color is equal to red. Okay. So what's this code gives us? So these codes will find passenger class versus age, and I'm giving X label as X label indicate class, passengers class, and Y label indicate age, and color indicate red color, so that we can able to look at here. So these are all various passengers class related ages. For example, first class related ages, that is one box plot. Second class ages, that is related to second box plot. And third classes indicate third box plot. Okay. Now what we understand, simple age, but we are looking categorically age. Okay. So in the make sense of understand, three categories are there, but three categories, they do have different ages. Okay. Now find out, simple concept like, first class. The first class, most of the people are above 20. You can see box plots here itself is, about 20 started, but we don't have any lower or upper outliers. Okay. Okay. So whoever, going into first class, they are the mostly distributed. If you go to third class, you can see there are lot of outliers are there, couple of outliers. Okay. So means there most of the ages in between very engaged. So 20 to 40. Here we can see 20 below. So much like 18 we can say. And this is something like, we can say this value. And what is this value which I explained? 1 minus 1.5 times IQR. That is this value. Okay. And here we can see this is ages, right? Okay. But the unfortunate situation here, fortunate or unfortunate, first class contains even a person is 80 age. Okay. 80 age is also there. So that's what. And in the similar way, we can say very early age people, just born age people, also some people presented here in this case, in these cases. But the focus is most on the here and box plot. But the second people, something like, they do have outlets and they do have median. Okay. Now, what is this numerical data? Like which I explained, numerical data. So we have to look forward for the, especially the box plot, but each indicate these values. For example, this indicate first quarter, this indicate third quarter, and this indicate second quarter, or in the means of, we can say, uh, median. This one. So median value slowly decreased with ages, with slightly class slightly increasing. So that is the mechanism it follows. Now, if you want to look at further, there is also providing finum, okay, and summary. These will give us more information. Just upload finum and summary. Okay. Now, what we got it here clearly, finum indicate age. Okay, 5 numbers, and we got in a clear way 0.42 and 20 and no something like 28 and 38 and 80. Okay. So don't forget about, this is a dot, this dot indicate point. It's not point zero. Okay. It's not point zero. It's indicate two different items. I'll just go to print. Let's see print here. Is there any change? This also we can just. The middle dot is not just like 4.0 or 5.0. So middle dot is nothing but this parts, this number separated, this number separated. Okay, so now we can see, now we got it here, previous 0.42 we got it, right? So small print is changing here. 22.00 is second, and 28.200 is third, and 38.00 is fourth, and 80.00 is fifth point. Okay, so that is what five numbers. Five numbers indicate what? Five numbers. First, it will indicate five numbers. Okay, so what is five numbers indicate here? So first is minimum, and second thing is first quarter one, we can say, and second one indicate quarter two, or medium, and third value indicate quarter three or max. Okay, and the last column indicate max value. So these are the 5-digit summary. So in the statistical we can say 5-digit summary. So 5-digit summary indicate a value it's taking into minimum and maximum and across total and total compared with quartiles wise, 4 parts. So in these cases we can say like how these ages might be, right? Okay. So the ages might be, we can say simply in these cases we got why we got 0.42. Okay. Maybe it might be wrong, one option, or it might be just born people like some 4 months or 5 months. In that cases, we can say. What is quarter one? Quarter one indicate if you just divide the parts into ages into 4 parts. So the first part indicate 20 age, and second part indicate 28 age. Third part indicate 38 age, and maximum value 80. Just now I explained 80 age. So this person age, this is the 80% age. Okay, this line indicate yearly. That is a person age which we got it. Okay? This value. Now, okay, these are the things, but this gives plenty of information about the story of the or that incident, and how they like what sort of ages, what sort of classes they are, and we have to make sure to understand these information. Now, what is summary? Summary provides same 5 digits, but it will provide all the values. Okay. So for example, you can take age. Just compare with age, so you might understand. So age, which I explained here, right? So this is value mean, right? So this mean value is this mean value, and which I explained comes from your phi num. So that value is this 0.2. Okay. Now same way first quarter, first quarter and 20.12. So that is what quarter one, or we can say first quarter, and that is what we are getting from here. Okay, so that is what here we are giving 20. Okay, 20.12, but here we are going 20.00, right? So in that cases we can say same in a similar manner. So this is what 28.0 is a double, and this is what to quarter two, and here we can see we got 28. So in these cases 28 something like mean. It's also providing mean. Okay, so it mean median. So something it is given, and lastly finally third quartile is also providing, and the maximum value is also providing. Yep. So that is indicate what 5 number summary. So or if you want to look at, just click on it here and a question mark. So can you explain the 5 and it will clearly explains this information if there is any change or something. Documentation, because this is documentation, not So this comes into from the documentation and it's giving clear phenom summary, right? Phenom, and it's indicate these values. So IQR box plot starts and median value. Okay. So this is a value which provides box plots related and all these values relevant with so many things like not only numerical data, it's also provide categorical data. For example, you can take assets, right? Length is 891, okay, and it's indicate class character and mode character. Why we are getting here six different values. See, the thing is for summary, it's not providing information how many male, how many female, and since it is a categorical data, it's clearly indicate character. So that is the reason I can't provide, we can't provide numerically, but I can able to explain that is a character. Same thing goes to names. So names, we can't find minimum name. We can't find maximum name. We can't find who is the first quartile, who is the, because how can we make, names into something like four parts? We should have some order, right? So when we need order, we should have numbers, right? So that is the reason we got here clearly. So length is giving and they are giving class character, mode character. So that is the reason we can't provide is different, but we can understand. It's a character related. But if you go to other things like server or not, that is also number. So that is the reason it's taking, even though number, category, siblings and spouse, count, number, and fair, number, and category number is there. And embark station, so that is also character. So wherever categorical data that we provide, but wherever numerical data, we got, clearly information about, how these values will be distributed and so that we can make sure to understand with the box plot and with relevant with, various kind of values. So these are the list of the package to describe the data. So if you want to go further, if you want to look at, more further, and if you want to understand the data, so these are the group of packages you can install and it will provide plenty of information. So these are all the information it's provided, okay. For example, describe is there. Describe will provide information like, all those things. These are all information. For single variable only, it's giving all this information. A library is there and similar information, and here in this similar information. So that is the main mechanism we have to look forward, but it's going into complex for you to understand right now. Okay. But we can provide, a couple of information like, how this data will be look like and how this data will be, make sure to provide all this information. I'm giving just for practice to make sure to understand how this data. For example, you can take simple example here. Every value here indicate column name. For example, passenger ID, and here gives variables one, and here indicate number total, and here indicate mean. So mean indicate, but it's not giving total number, but it's giving into like larger number. It will provide a, E plus number, so that you can understand it's a larger number. That also we can get the number, but we make sure to understand it's larger. And this one indicates standard deviation, and this is indicate median, and this is indicate trimmed median, and this is indicate mean absolute division or something, and this is minimum, this is maximum, and this is range. Okay, so it's going further and it's giving all this information. Okay, so all this information and this variables are nothing but which column, first column, second column, third column, fourth column, fifth column, and this sixth column. And here indicate how many. For example, sixth column we have 714 is there, no? So what about rest of the things? Totally 891 people, they have ages, but unfortunately 891 minus 714 people, they didn't have ages. Means in the data. Maybe they didn't provide ages or it might be missed out. That's an optional maybe. For example, a form fill up for you to give and I'm giving age as a simple column. So I'm giving an optional. You might choose, somebody might write. So that is the information is going on. So those are not available values and we can make sure to understand. Okay. So in the similar way, just go ahead and we can make sure to understand, how the values will be, rest of the values and provide all this information. Now we will move forward and we can make sure to understand not only these values, but I give it couple of, information after, these values and the file number we are looking and directive. But here we are going further like psych package, HMix package and paste text package, summary tools. This is only package which I installed for the describing data, but we have such packages are there like schema and StreamYard. These value stargazer, I think. So very far away I have been used last, but we'll just go ahead and we can make sure to understand the data, how packages will help us, plenty of information to get into understand the data. Okay. So that's about the total, and we have to look forward for adding so another things like inference statistics. Still, we are waiting. So what topics we have to cover in inference statistics? I will provide it in the clear way, of information here. So we do have a couple of methods are we have run. I think this value which I indicate here. This is a code, I think a screen problem issue, something. Okay, we'll meet up and we'll discuss into next concepts. And along with this I will explain again. The screen something problem is show something. I look forward and I can able to go ahead with few examples and explain the concept, right? So thank you, and we'll meet up in the next session. And thank you very much.